About to start the July 10th meeting, and this is a CAD collaboration. So I will be recording and sharing this with DiscoBots Canada. At this point in time, I'll turn it over to Sawmill first, and then we'll move to the other team with Peter afterwards.
The main innovations we have made right now are in some climber mechanisms. Specifically, we found that probably the clamp is the most integral part to get correct on the climber. So we have some prototypes. Firstly, we had this kind of concept. It's just a clamp like this, where you would have another wheel here, and the pole would go in between. The initial idea of this was to make it an over-centered joint. For example, if you could attach the pneumatic from here to here, you would be able to get both of these to clamp and it would lock in an over-centered way. But just to simplify the prototype for now, we added the pneumatic at the bottom in this kind of linkage. It worked quite nicely. We estimate that it could hold up one robot, but perhaps not two if you want to do a buddy climb. So then we identified the main reason it didn't work was because when we do clamp, the surface area is like the flex wheels are not even flexing. Even if you use the gray ones, they don't squish down. So you're basically just going on the tangent and you have very small surface area. To solve this issue, we came up with some kind of a custom plastic spacers on these tips of the claw so that you can look, the plastic gives it a little bit of gap. And in this exact measurements, the way we CAD'd it in laser cut, it very well takes the shape of that pipe. So even with one of these flex wheels, the force to grate these two together is quite high actually. And with a lot of them, for example, of course, we'll have one on the other side. And along with that, if you can put one in this central location right here, with all these curved flex wheels, you would get a lot. And then of course you could build it double decker. So on top of one flex wheel, you could put another. And with this, you'll just keep on getting more and more traction from our experience, at least. And it makes it very easy to climb. So we're making some good progress on these clamps. We didn't see much on the internet. So hopefully this is a promising design. Would you just like to share something about you guys' robot?
Okay, so I have been making a CAD model. Share. All right, unmute that with laptop, and I'll mute this. Now you're talking.
Yes. Hello. So we made our CAD model. Yeah. So this is our current CAD model. We have an arm design right here that will pull the tri-balls in and up. We're not going to load them directly into the catapult because from what we saw, that isn't really necessary. All that ends up really happening in matches is the catapult is used for the match loads, which can just be set directly in the catapult, and the intake is used to just move tri-balls around to get them in the goal. So we're just going to use it for that. And then here's a little prototype catapult type mechanism. This isn't really our final design for the catapult. I just wanted something in there to approximate how much space it would take up. Other than that, we're not really gearing our motors. We're just going to have them be green, but all the wheels are connected together by the gears that we do have. it's using one 5-segment less cut C channels. So it's nowhere close to the limits. So we can expand slightly if we need more space.
Just to clarify, this robot is a separate CAD from the one we showed you before, because these are two separate robots. Separate.
Yeah. Yeah. Okay, I think that's it.
All right. Let's try to make it fill up. Yeah. Still loading. It's a big assembly.
Mr. Saxena, are we expecting more guests?
No, there's not. There won't be any more members from us today. Everyone's here. We're building the field actually.
Okay, Sawmill and Lorenzo, you guys are going to continue now. If you can unmute your microphone and just have this volume from right
I
here.
think we're unmuted. Yeah,
Turn on this volume from right here because the speakers are just too overpowered.
makes sense. All right. Continuing on our robot, you might recognize from previous time with these special ramps to go up, our wheels that are drop center downwards, or not drop center. The shaft is just in the lower row, and our catapults. The main addition we have now is these intake arms. They're kind of simple. They just use a half wattage motor with some sprocket ratio that we had found other people used online, and they're going to be attached to the C channel. Right now it's just floating, but going to be better.
Minimize your
show them
data
around.
panel so we got more
Right.
screen.
You can show them around the robot. Just look at them.
So, hello, my name is Lorenzo. And this will be a 6-motor drive. As someone said, this is a flywheel that we came up. It's a simple not flywheel. I'm so sorry, an intake. And here you can see our catapult. Later on, we will insert our climbing mechanism as Samuel showed earlier. And that's basically it from last meeting. We had similar things. There were no big changes in it.
Yeah, so I don't fully remember how the status was last time, but I think maybe these weren't visible because didn't make them yet. Now you can see this is where the 6th motor is, and this is where the PTO would be. So these gears would be, of course, shaped on the side because we're planning to use all 6 motors of the base to climb our robot, which hopefully is a buddy climber. And that's where it'll be attached. So we have so much of space for our climbing mechanism because this entire robot is supposed to fit underneath the horizontal bar, which is about 11 to 12 inches. So I believe this line over here marks the top of that bar. That means our clearance, how much we can go. But luckily, we have so much space around our catapults that any of our climbing mechanisms can fit on the side beside them, and they can be 18 inches long, so that when you have to expand up and the whole shaft comes up, or the whole C channel comes up to climb, then it will be quite tall, and we can just easily reach the top and only use one pivot point to get up there without needing too much complex things, especially since we have the power of 6 motors. That's basically it. Yeah.
Okay, do we have any updates from Canada?
Can you guys hear me? Can you guys hear me? Hello? Hello? Oh, I can't see the chat. I'm not sure if you guys said something there. All right, so basically we just got our field
We can hear you.
yesterday. Okay, sorry. So we just got our field yesterday. So today we're just building the field, like right now. Other than that, we haven't really been able to CAD or build anything. Like I think a lot of our students had like early admissions exams. So we just started like July. We just started all of our progress again. We've been like halted since June. Right now, I think they're planning. So with the 3 teams that we know we're having, one of them is planning on building a drivetrain with the 3.25 inch wheels, which I don't know. We're like questionable. We're still testing that out. But I think the plan right now is we're gonna start with a drivetrain and then build up from there. We just built one of the goals, and now we are reconsidering the puncher that we said earlier. But I think we're still gonna get one team to at least try out the puncher because we've seen it is possible, but it seems like it's a tolerance on how the goal is built. So it does look really hard to put it in from far, like to punch it. But we're still gonna attempt that though. Right now, we just built one goal, like literally like right now. So yeah, we're like kind of excited, but I think we're gonna try out a puncher robot, and we can let you guys know how that works.
Yeah, we were able to visit a field setup from another team. We had it set up once, and it was surprisingly easy. Like you could do a bowling ball type of thing and just roll the tri ball, and it still went in. So whatever tolerance they had was kind of made up, honestly.
I don't know. For us, I'll show you
Tolerances
right
are going
now.
to be different on different fields.
Yeah, it looks.
So
Yeah, like right now, for us, it looks pretty hard to put. Here, we just built this
It's too
goal.
hard.
Yeah, this is a goal we just built, and let's say like you cannot roll it in from the side at all. Like it always gets stuck. Like you actually have to put some force in it. I'll show you. So like this
Alright.
is, and then like you can see it's like stuck here, and you actually have to like the pipe has to bend through. We noticed because the pipe that we got is slightly bent, it's like really loose in this area. This area it just rolls in straight like that, like literally nothing.
That's the one that we rolled in.
And then over here, it's weird. Like over here, it's hell. It's like very much different. Over here, it takes way more force. So I don't know how it's gonna be in a real competition, but like from the looks of it, I think it also depends on the angle you throw it at. Because we tried throwing it from like further away, but obviously it's not a robot; it's like a human. But we were able to like make some long range shots. So I think we're still gonna attempt the puncher. But yeah, it definitely.
I also heard you mentioned. Oh,
Pardon?
sorry. Go ahead.
No, you can go ahead.
All right. I was just talking about the drive base. I heard you mentioned 3.25 inch wheels. Any
Yeah,
reason specifically?
No, I don't know. One of the teams saw a video on YouTube. I think I saw it earlier. It was like a month ago, and it's a robot that has like Lexan slides and 3.25 inch wheels. I don't know the specific reasoning behind why they want that, but I think 3 inch is probably better because the bump looks pretty big. So I don't know. We're like really early testing stage right now, so we're gonna see. One more thing that we noticed is when you like punch the balls like off the ground, like if they're like sliding on the ground, like if they slide like this, then they're actually then it's really easy to put them into the goal. But that's only like possible for half court though. So yeah. Right now that's where we're at, like really early on. But yeah, I don't know.
the only reason I can think to use the smaller wheels is if you are worried about getting under the crossbar. So using smaller wheels, you might be able to get more actual mechanism under there.
Yeah, that's true. Okay. All right. Yeah, I don't know. We're gonna have to see it. So far, our teams are kind of like they're like kind of like split. Like everyone's thinking something else. I'm not really sure what the main idea is, but I think I'm just gonna tell everyone to try out different things since we have like 3 or 4 teams, and then whatever's the best, we'll stick with that.
Yeah, that's the interesting thing about this game. You don't know for sure yet.
It looks like it could be anything. I don't know, because catapult will
Yeah.
always, but puncher, if puncher does work and long range shots are capable like of happening, then that seems like a really good thing. So it's worth a shot.
Especially since puncher probably has a higher arc radius. You don't have to go over and under it like us.
Yeah. So we'll see. If it works out though, we will tell you, and then hopefully we can switch all the DiscoBot teams to like the better design. So
Yeah.
have you guys started building it, or is it just CADing right now?
For us,
Yeah.
we have some stuff built. For example, our drive is almost finished. We have like the 2 halves. It's at my home right now, so I can't really show it. But
No,
it's
that's-
almost exactly like the CAD, and it's pretty good.
All right. Yeah. Just let me just. I mean, do you guys have Discord, or like is the best way of communication just through meetings? Because if there's like a messaging, or you can.
I
message
think, yeah, I can give you my phone number. That's probably best.
Oh, I mean, email would work out better because in Canada we don't really have like North America calling and texting. So yeah.
All right,
yeah.
sounds good.
I'll just.
Yeah, I can give you my email.
All right. Yeah. That would be better. That would be better. We can like email and ask for updates because right now like if we can see that something is good, like if we see your drivetrains working and crossing the bump, and if it's within like the dimensions we want for our puncher, then we can just use the same type
Yeah.
of drive.
You want me to type it in the chat?
I can't see chat on mobile. I don't know where it would be. Hey, I'll send him. I'll tell him an email. You can note it down.
All right.
Guys, we can also use this channel to create more meetings whenever you need.
Okay. Yeah, that would be fine as well. Can we chat on Teams? Is that possible? Like when we're not in a meeting? I don't.
I think we probably could.
Yeah, I don't. I just don't know how to set it up. If we can set that up, then that would be fine as well.
All right. I think I have one of the emails of one of your teammates. I think I forgot his name. Started with a P probably.
Starts with a what?
Oh, that's the coach?
Okay, that's fine. Yeah,
Never
that's
mind.
fine. We
I have to coach.
can use email too. Well, we can use coach's email too. All right. That's how we'll contact you then. Okay. I think I like the idea because so let us know if your drivetrain works. You can just email us, and then if it does work out, then we'll use that as a basis for one of our robots because it'll save our time.
Yeah, our CAD is also public. I think we had the link from last meeting somewhere in there. If you can find the last meeting.
I think we tried like pulling it up after, but I don't know. I don't know. It wasn't able we weren't able to load it last time.
All right.
Yeah, I don't know. Oh yeah. Okay. Yeah, if you could send that again, that would be good.
Of course.
All right. Thank you. So yeah, that's the updates that we have
That's
right now. Other than that, we don't really have much progress.
Okay.
And then yeah,
That's all right.
And then I think what is it? We talked to Carnage a little bit. I don't think they have much progress either. I think they're just in the early stage of design right now. But I don't really know what they're doing. So yeah.
Yeah, I saw we have our Slack with them, and I
Yeah.
saw they have some type of rough CAD. I saw something with standoffs.
Okay, that's good. What time? When do your tournaments start for you guys? When is like the beginning early season?
Our early season, I guess September.
Oh, okay. Ours is usually later. That's why Canada's always like running a little bit behind. Normally it's November for us, but right now it seems like there's some teams that are pushing to do earlier tournaments. So yeah, we'll see what happens.
Yeah.
All right, we're gonna try having a robot within like 2 weeks.
What date was it? Yeah. We're even hosting a tournament at our place on October.
Oh, okay. Right now, our goal is to have at least a prototype robot, like at least one robot from all the teams before July ends. So probably like mid-July, we're hoping to have one robot.
That's pretty good. That's a good goal.
All right, yeah, that's all I have to share honestly today.
All right. Thanks for meeting. Yeah, if you ever find the chat, I left my email there, or you can put yours and I'll be able to see it. If not, then we can talk some other way. I'm sure you can find my access.
Because I can't see the chat because I think I'm a guest. That's why.
Yeah.
Like, great.
Or your captain from last year. I think I got his contact somehow, or he has mine. I meet him at Worlds.
Oh, I mean, I was the captain last year.
You as well? Okay, then maybe it's some other guy.
Yeah, I don't know.
Was it the coach's son?
Yeah, I'm the coach's son.
That's you? Oh.
Yeah.
Maybe I have your email then. I don't even know.
Okay, I don't know. I
forgot.
don't have email, so that's weird. But okay, I'll get your email from my dad though. But I'm not. I'm in high school. I'm in university, so I'm just like mentoring the high school teams. But yeah,
Okay, makes sense.
but yeah, I'll get them to contact you though. All right.
Alright.
Okay.
Thanks
Thanks
for
for meeting.
coming.
I like your shirt.
Okay, I will be sharing the recording, so expect that to come in your email.
All right. Thank you.